Hello everyone. In this video, we are going to see about what is synchronous and asynchronous execution in distributed computing and what are the design issues and challenges in distributed computing. First, we are going to see about what is synchronous execution. Synchronous executions refers to that one task must finish before moving to the next task. For example, if the first task is running means it have to finish its executions before moving to the second task. In synchronous executions, the lower bound and upper bounds on executions are set. For example, if the message have to be delivered within 10 milliseconds to 15 milliseconds means the lower bound is 10 seconds and the upper bound is 50 seconds, so that the message should be transmitted within the known bound of time. For example, it should be transmitted between 10 milliseconds to 15 milliseconds. In synchronous execution, the drift rates between the local clocks have a known bound. The drift rates refers to the difference between the time in the local clocks. Next, we are going to say about asynchronous executions. So, in asynchronous executions, two tasks can run in parallel so that the second task need not wait to the first task to finish. Here, there is no lower or upper bound on the executions, so that the message can be transmitted with no bound of times. In asynchronous execution, there is no bound on drift rate between the local clocks. Next, we are going to say about the design issues and challenges of distributed computing. There are some challenges from system perspective. They are communication mechanism, processes, naming, synchronization, data storage and access, consistency and replication, distributed system security. First, we are going to say about a communication mechanism. So, in a distributed system, communication is the most and important thing. So the designing should choose an appropriate mechanism for communication among the processes. So there must be a conflict between which mechanism has to be selected, either RPC or ROA, that is remote procedure call or remote object invocation. The next one is processes. So, if n number of entities are connected within a same network, the code migration process management between the client and server and the software design are a tedious one. The next we are going to say about naming. In naming, each system has to be identified. So for that purpose, we are using identifiers to locate resources and processes. So naming n number of entities is a quite difficult one. The next one is we are going to see about synchronization. So in a distributed system, the coordination between the processes is essential. So which mechanism has to be selected for synchronization plays an important role, either a mutual exclusion or leader election algorithm. Next, data storage and access. The main purpose of distributed system is resource sharing. So while resource sharing, the searching and lookup should be fast and data storage is also essential. The next one is consistency and replication. To avoid bottleneck and to provide fast access to the data and replication for fast access, scalability, this requires consistency management among the replicas. Next, distributed system security. So, in point of security, we have to confirm the secure channels and access control and authorization of access and group management. There are some challenges in distributed computing. They are heterogeneity, openness, security, scalability, failure handling, concurrency, and transparency. First one is heterogeneity. Heterogeneity refers to the different configurations. For example, the differences may be in computer networks, that is either LAN, Wi-Fi connection or satellite link. In hardware devices, it may be a laptop, PC, mobile phones or tab. For in point of operating system, one system may has Linux operating system, the other may has Unix and the other may has Windows. Then programming languages, so C, C++, Java, HPP, there are different kinds of programming languages, so it plays a vital role. The next one is middleware. A software layer that provides a programming abstraction is known as a middleware. Then, code suitable for one computer is not necessarily suitable for running on other another. So there must be a perfect software layer for these type of issues. So middleware should make the network transparent to the applications and end users. The next one is openness. The system can be easily extended and modified. So if we are going to add a new component to the existing components, the architecture should be suitable to allow the integration while preserving the previous investments. The next one is security. When it comes to security, there are three components: confidentiality, integrity, and availability. So in point of confidentiality, it's the protection against unauthorized access. The next one is integrity, is the protection against alteration and corruption. The last one is availability. So each resource should be made available to the users. Some types of attacks may be occurred. For example, denial of services, it makes the services unavailable to the users. Okay, next the remaining we will see in the next class. Thank you.